Hey calculates, welcome back. So we're picking up here still on page 1 or P1, chapter P1, and going over some review stuff. We talked about this interval notation stuff in class the other day, but I just want to emphasize it again. So when I have the brackets, if I'm looking at a number line with A and B on it, that means that it's closed for both. So I would have a closed dot at both, which is why I use the brackets, and then it would contain everything inside. If I'm looking at parentheses, then with A and B on the number line again, this time both of the dots would be open, and that's why I use parentheses when I have open dots. So on the next one, since I have a bracket on A and a parenthesis on B, then A gets a filled in dot, but B has an open dot. And again, everything on the inside. And then on the last one, since now the bracket is on B, and I have a parenthesis on A, that means that A is open and B is filled in, and again, everything in between. And so when I do infinity, so if I'm going from positive infinity to negative infinity, all infinities always have open because there's no real number there. Oops, I forgot to make that a negative infinity. So yes, anytime you're using infinity, you should be using parentheses because that's considered to be open. So if I look at this example, x greater than 2, and I think about what that looks like shaded on a number line, of course it would be everything greater than 2, so I'd have open circle at 2 and then everything to the right. So if I were writing that in interval notation, I would want a parentheses for 2, and then I'm going to positive infinity, and that always gets a parentheses. Versus on this second one, less than or equal to negative 3, so at negative 3, I would have a filled in dot, and everything shaded to the left. So in interval notation, I would have negative infinity, so that gets a parentheses, and then closed at negative 3 gets a bracket. Okay, so simplifying with some function notation, over here I have to do f of x. Well, I know what that is, and I have to subtract f of 1. So I'm going to come back over here, and I'm going to find f of 1, of course, by plugging in 1, which is going to give me a grand total of 0. So f of x, then, is still x cubed minus x, and then I'm subtracting f of 1, which is 0, over x minus 1. And so if I simplify this, I'm going to go this way. The top is x times x squared minus 1 over x minus 1. And of course, that top is going to factor to x minus 1, x plus 1, because it's a difference of squares, which means my x minus 1's will cancel out, and so I get a grand total of x times x plus 1. Final answer. Problem number 2, because this is a calculator problem, I am going to make sure that in class on Monday you actually know how to find these points of intersection with your calculator. So I would suggest that you kind of review. If you remember, you're putting these into y equals so that you can graph. And then I'm not sure if you know how to find points of intersection, but after you've graphed those, you want to go to Calc, and then there should be an intersection as a choice. And after that it gets a little tricky, so we'll talk about that on Monday.